Hey, Vaquero Nation. Just a quick reminder, the views expressed on RGV Community Health Hour are for informational purposes only and do not constitute medical advice. Be sure to consult your primary care provider for all your health care needs. Today's guest is Dr. Jacob Galan. He was the first guest of my show at the beginning of the semester, and we'll be with him after this short music break. Thanks for tuning in. All right, everyone, and we're here with Dr. Jacob Galan. So, Dr. Galan was my first guest of the season this semester. And also, because there were some technical issues, I thought it'd be good to have him on and kind of reiterate some of the stuff we talked about early on. And we also came back from a conference recently, but that can be talked about later in the show. So for now, thank you, Dr. Galan, for joining me.
Hey, thank you for having me.
Yeah, of course. So I thought it'd be good to start off with the PhD program and talking about our PhD in Human Genetics program. Our new building just had the recent cutting ribbon, ceremony to officially open up.
Yep.
So, what do you want to tell our audience about our program?
Well, first, thank you. Thanks to all the people out there listening. My name is Jacob Galan. I'm an associate professor of medicine. I'm in the Department of Human Genetics, and we do the people science. So so that's one of the cool things about like UTRGV in the area, and the opportunity for doing research and the potential for really finding like really amazing, amazing students, equipment, state-of-the-art instrumentation, and then also like really great faculty. Getting to work with like people that are kind of wild and have great ideas, and then you get to see that like happen, right? So I'm on my soapbox at the moment because anybody going to the university will automatically get an education, right? That's theory. But what people don't realize and never really take the opportunity is to do research and to get that applied, hands-on experience, right? It's something that is super important, and you can make a career out of it, right?
Yeah, that's one thing I've been mentioning on my show over the last few weeks is talking about all the undergrads that we have in our lab volunteering in various capacities. So I always kind of try to preach like, hey, if you're interested in this, or even if you're not, just come by and check it out, and tell a friend or, bring some friends. And yeah, so it's really remarkable stuff that we have in that new building and even in the old buildings too.
Right, yeah. I mean, you literally can get paid to learn, because that's what research is, right? So it's just a really amazing opportunity, and people don't really think about that. So in the Department of Human Genetics, my area of expertise is in high-throughput technologies, and I focus on, my discipline is in the area of toxicology, and it goes from everything from biological toxicology to environmental toxicology, and how that impacts human health and disease.
Yeah, so just real quick, a biological toxicology would be like snake venom and toxins coming from
Fungus.
Yeah. And so the environmental toxins could be air pollution and things like that. So just making sure our non-science audience can follow.
Molecules, good point. Small molecules, carcinogens, stuff found in cigarettes and vaping. These plastics, benzoate-pyrene, there's a lot of like really, nasty molecules. Heavy metals, it's another one, not the music genre, but like the, lead, mercury. These are really, stuff they find in a lot of industrial waste. So one of the biggest concerns here in the Rio Grande Valley is that we know we have a massive increase in people with diabetes. We see massive increases in Alzheimer's disease and in cancer. Actually, some of the highest rates in the nation are actually here in the Rio Grande Valley. And the thing is, they don't actually increase with respect to heredity and heritability. We believe, and the data shows that they're actually are caused by environmental factors because the rates are just they're too great. So we are dedicated to looking at to doing studies dedicated to gene environment interaction.
Yeah, and that's one thing that I found kind of interesting in terms of joining the program was, I didn't know what to call it before joining the program. I was just like, hey, I'm interested in how the environment makes us sick, because it's kind of interesting to think about, and usually I think, especially before the program, I thought about it in terms of, like areas of high radiation like Chernobyl and Fukushima, or terrible disaster sites like the
Ohio River, yeah.
or that too.
Yeah.
But recently, like in the last year or two, with the train derailment that caught fire, and I can't remember where it was at.
Military burn pits.
Yeah, that as well. So,
Yep.
but I think the two most prominent things that people think about is probably those burn pits, because it's kind of on top of, was on top of the political landscape for a while in terms of getting all that legislation passed to help veterans. And then, of course, also, like I said, everybody knows about Chernobyl, I feel, in terms of like, just the story of nuclear.
I hope they do. That was a long time ago. But
Yeah, but still, it's just a historical event, the first big meltdown in radioactive kind of disaster site.
There's a strong program here in environmental sciences looking at emissions and looking at, you don't like, in the Rio Grande Valley, they have like these burn offs, right? This is not good. This is not good for people to like, be exposed to.
Yeah, and that's one thing I've been thinking about recently too, is how, how a lot of the people that moved here to research the disease have kind of, whether they willingly did it or know it or not, they kind of took the leap in terms of getting into the fight with the people, like living here and being exposed to the environment while also trying to help, the community.
Yeah. Oh yeah, absolutely. Like, I mean, so we have a diversity center. The UT RGV Diversity Center for Genome Research, and part of our mission is to not only do the research and incorporate students into these projects, but also to develop a workforce to train students from the Rio Grande Valley for these specific types of diseases, right? And on top of that, a part of that diversity center is engagement with the community, so that what we uncover and what we find is actually those results and those, kind of action plans are disseminated to the community at large, because we say in the department, we do the people science. I'm actually from South Texas, so it's kind of near and dear to me to, talk about this. I talk about this, constantly ad nauseum. We see obesity rates really high. You have to think about quality of food, lifestyle, all these factors. The research is getting way better, and we can sequence genomes a lot faster and a lot less costly. Our technology, is allowing us to see and really dissect the molecular underpinnings of, what is causing these these chronic diseases, right, which are multifactorial, but genetics plays a big role in this, right?
Yeah.
So,
and I think, one thing that's interesting about that is I'm kind of going to jump ahead for a second here. At the conference we just came from, I sat in in one of the seminars or the talks, and it was the MVP, the Million Veteran Program, in terms of like the VA recruited over 1 million veterans since I think like 2012 to, basically give up their, be a part of this full genome sequencing program. And it's meant to, benefit veterans. And recently, I think, so they started the program in like the early 2010s, and here in the early 2020s, they started, I can't remember, I was just trying to look it up, but it's basically their attempt to use that data. It's MVP, and it starts with an R. I want to say it starts with RO, because it's like results-oriented something. So basically, they want to take all that data from the veterans And now that we are so much better at understanding the genetic, and like I said, they started it in 2012, and now 10 plus years later, science has advanced so much. We understand so much more about these genes and pathways that they're trying to use it to inform veterans about potential genetic disorders, that they have like rare variants that are linked to these weird diseases, and they're letting these veterans know, like, hey, thank you for being a part of this program, and now we want to let you know that you could be susceptible to this based on your genetics.
Right. Yeah. For sure.
And so that's what I loved about going to that talk, was just to see how the VA is not only just grabbing the data to use for scientific purposes, of course, but they're also trying to have like a results-oriented action plan to try to help the veterans that are giving the data up.
Yep. Yeah.
And so, that's kind of my hope one day for our cohorts, and I know it's kind of happening now in a sense. We try to recruit people to our studies and our, projects, and we get information from them, and the ultimate goal is to try to make the community healthier and better. And so, overall, it's a good thing to try to find these SNPs that are involved, or like these changes in the DNA, these single nucleotide changes in the DNA that could be, disease causing or things like that. So ultimately, the whole goal behind all this work is to get to the point of personalized medicine, where we can tell people, like, hey, based on your genetics, take these medicines and not these medicines, or do this and not that.
Yep. Translational research and for precision medicine or personalized medicine. Yeah, that's where we're headed. It's a game changer.
Yeah, and so do you want to talk about GRASS a little bit? So we have, I have mentioned it before, we have our Genetics Research Association of Scientific Scholars.
That great name.
Or GRASS. And so we have done 2 meetings this semester, and basically we just get together, do a journal club. That's what it's been so far this semester, is a journal club, where we get together to discuss scientific papers and just kind of get into that rhythm of genetics, research, and trying to pull ideas from other papers and other, fields of the science. And so it's been really interesting because, we gave our first talk, my classmate Marco and I, we did it on, I want to say, sorry, it's been a minute. Lots of stuff happened since then, but it was on liver and like toxin.
Aflatoxin?
Yeah, I want to say it was aflatoxin.
intestine.
Yeah, there you go.
Yeah, that was interesting. So that's something we're working on, in our lab. Something Marco's been working on. Aflatoxin is found on just about every crop, where you get a mold and you get, is it Parasitillus aspergillus, right? Is that the name of the species?
Yeah, I think so.
And Flavus is the other species, right?
Mm-hmm.
And so you get this mold, and this mycotoxin, and it's a secondary metabolite, right? So it's just a basic molecule. When you consume it, it gets actually bioactivated in the liver, where it becomes 1,000 times more toxic. And they first discovered it was genotoxic, right? So it's binding to DNA, forms this adduct, and it just so happens that it's in the place where you have the p53 tumor suppressor gene, right? And that is important for a lot of different processes, right? Obviously, tumor suppressor, it blocks the tumor suppressor gene, so you're going to get tumors, and that's what they found in the liver, right? And that's where it most likely shows up, is in the liver. And so we know we have a lot of cases of liver cancer here, and also non-alcoholic fatty liver disease, right? Which they found that this mycotoxin can actually exacerbate non-alcoholic fatty liver disease. It causes, increase in lipidemia, right? And there's been studies that have, I think it was back about 15, 20 years ago. The aflatoxin is on a lot of corn products here, right? It ends up even in processed foods that you find on the shelf. There's an allowable amount, 20 parts per billion, that you can consume, that's regulated by the USDA. So it's a huge problem. It's well studied in China and in African countries, and where typically you have issues with storage, you know, and where you get this overgrowth of, you know, this particular toxin, and you know it can wipe out whole communities. They've seen it actually affect. It can get passed on from the mother's breast milk to infants. That's something we're also looking at in the lab with Dr. John Vanderberg, looking at aflatoxin in terms of development. Because what it's shown is that as children are nursing from their mothers, and they have high levels of exposure to aflatoxin, they can develop actually they could have cognitive impairment, deformities in cranial and maxilla, and what is it, mandibular, like basically the mouth or the jaw,
Like jaw deformation.
Yeah, exactly, jaw deformation. So now it's a serious concern, right? So we just don't know how much is here. Apparently, the state of Texas self-regulates how much mycotoxin you could have on your corn, which is a kind of interesting.
Yeah, so that was a whole interesting kind of ordeal.
You should tell how they.
So
Who did we call again?
the Texas,
Chemist?
the Texas State Office, or no, the state.
State Chemist Office.
Yeah, the Texas State Chemist or
Yeah,
something
there
like
you
that.
go, yeah.
The Office of the Texas State Chemist. That's what it is.
Very honest with us.
Yeah, and it was a great talk
Actually
and a
should have
great.
been.
Yeah, so you know, this highly, this potent toxin is in the food system, and it's highly regulated, like Dr. Galan mentioned. And here in Texas, we're the only state that regularly mixes our high contaminated corn with our non-contaminated corn. Like dilution is the solution, as they say. And so we're the only state that regularly does that.
I was gonna say, they say 20 parts per billion, but there's data out there that shows that this genotoxicity, and there's more evidence that suggests it's beyond genotoxic effects, right? It can activate reactive oxidative species, inflammation. It can do a lot of things. And back to the original grass paper that you guys talked about, the serious concern is that it accumulates. So it's an accumulation effect. Like, even though you're getting at 20 parts per billion, you eliminate it. I'm not trying to scare everybody out there. If you have phase 1, phase 2 detoxification enzymes, right, that eliminate it. But if those are compromised, or those over time become compromised, then you're screwed, right? And so they've shown that there's a capacity at some point where the cell just says, shit, I'm done. I'm done, right? I'm like, I can't do this anymore. And then thus you get the kind of the carcinogenic effect, right? And you get more exacerbation of this toxin affecting other downstream systems. Now, with respect to that paper, which was interesting, was that I wasn't really thinking about this too. And there's other data that shows it can actually it can cross the blood-brain barrier.
Oh,
once
no.
It gets once it gets into systemic circulation, gets into your blood, you can also eliminate it from your urine, right? We can see we can actually monitor the metabolism of the individual by monitoring aflatoxin. But if it can get into the blood-brain barrier, and there has been some they've shown effects or linkages and associations to Alzheimer's disease in other countries. Similarly, they've shown that it can actually, you have activating enzymes in your intestine and colon, and it could also be, and that's what that paper was showing, that there are these mycotoxins can get activated in as you eat them.
Yeah.
Right? It's just like food exposure. It's really interesting. And guess what? We have high rates of colon cancer here in the Rio Grande Valley. We have high incidence of liver cancer.
Yeah.
We have high rates of Alzheimer's. So this toxin may be the culprit.
Yeah.
One of the factors.
Yeah, one of the many various environmental exposures that
Yeah.
So with that, we're going to take a quick music break, and we'll be right back, everyone. Thanks for tuning in. All right, everyone. Thanks for staying tuned in. We're back with Dr. Jacob Galan, and we have an audience question that was sent in.
Uh-oh.
So a question for Dr. Galan. It seems like we're on the brink of a transformative era in medicine. How do you envision this next phase in health research?
Oh, that's a great question. Um, so like I mentioned earlier, I think we're moving into the era of translational research, right? From bench to bedside, and then
Mm-hmm.
precision medicine.
Okay.
Yeah, and it's already happening. I mean, if you go look at a lot of these clinics out there, you can get from a simple swab,
Mm-hmm.
from a mouth swab, blood sample, we can know everything about you, and that's a good thing, right? This is a good thing. Data and privacy is another issue. I wouldn't be too worried about. I mean, you should be worried about it, but the way this kind of at the end of the day, the more information you have about yourself in terms of healthcare, in terms of treatment, because of what we know from genetics, right, and from
Mm-hmm.
like human variation, it is we're going to get away from this one size fits all model, right? And so that's why I think we're in a new era where we were talking about precision medicine, right?
Mm-hmm.
I just came back from getting blood work, every year. Uh, don't worry, I'm fine. Everything is great. Um, but they tell me I'm overweight.
Really? That's
Exactly.
kind of absurd.
Exactly. Yeah. So So it's like, and they always say no, you're not, and I'm like, yeah, I know. Like this is like this kind of like this
Mm-hmm.
one size fits all model
Mm-hmm.
is not working. It's terrible, right? I'm gonna get on my soapbox a little bit because I have cholesterol. Cholesterol is very important for you, right?
Mm-hmm.
It's used to make all kinds of like hormones, testosterone, right? It's used for used in cortisol. It's an important feature for brain. An important feature and molecule for brain development and neurocognition and everything, right? It's an important molecule.
Mm-hmm.
Yes, it can in high levels, or the ratio of good and bad cholesterol can be bad for a lot of people, but the general consensus is by doctors or by this having a cholesterol level of like 200, if you're above it, they try to, they automatically, prescribe you a statin.
Mm-hmm.
Yeah, but statins are not good either, right? And the data on there is pretty, marginal that they're really effective, right?
Yeah.
So, because once again, the variation of being a human is staggering, right? And that's what we're interested in the Department of Genetics, right? There's metabolic variation, right? And really fine tuning our understanding of disease and or understanding genetics and how they contribute to disease, and then us also the environment, right?
Mm-hmm.
We're going to get to that level of healthcare. So that's a great question.
Yeah, I think it's pretty cool to think about, like, in the near future with these people who have the smart watches, the Apple Watch and the other, Samsung watches. In the near future, based on your genetics, that watch will be able to tell you, like, hey, don't walk down this block because there's something in the air or there's something in,
Right.
on the
Yeah.
walls that if you touched, you could be more detrimental to your health versus the person walking next to you.
Right. Exactly.
And so all these variations in human, condition, I guess, whether
Yeah.
we're, it's a protective variant or at-risk variant, or however it's.
Exactly right. Yeah. I mean, if you were to undergo an extensive analysis of yourself, right, and you knew what you were more susceptible to, that's a good indicator that you shouldn't do it, right? You shouldn't be like around, maybe alcohol is a good example, right?
Yeah.
Could be exposure to smoke, right? Or smoking.
Yeah, that's what I was just thinking is smoking, because
Yeah.
those are personal choices, and so at the end of the day, but at least you should have, like, everybody knows smoking is bad for you.
And or it's either some kind of family or genetic component to it, right? You see it in your family, right? But to know that offhand and have that information, right? It's just like there's just your own bodily warning labels, right?
Yeah.
I know I'm very sensitive to the types of food that I eat,
Mm-hmm.
and I see that in my family. A lot of diabetes, right?
Mm.
Guess what? I don't eat a lot of crappy food, right? I avoid it at all costs. I've been doing this since I was like 16, right? Because I know, when if I consume it, I feel like crap, right?
Yeah.
It just messes me up, right?
And it's funny, this reminds me of when I was living up in the Seattle area before I moved down here for the program. I'd get off work, I'd go to the local bar right by work, have a couple beers to decompress and work on my book and do other things. And, I would try different beers, and there was this one beer that for whatever reason it would make, because I have a busted leg. I need to get it fixed up and probably get surgery.
Yeah.
But for whatever reason, that beer would blow my leg up. Like my body would
Oh,
react weird to that beer.
Yeah.
And at first I thought it was something that I did, like to torque my knee weird, or maybe I was kneeling down too long, or maybe it was something physical that I did.
Yeah.
And then I was thinking, I was like, no. And then a couple days later, knee got better. I had another one of those beers, and it blew up again. And I was thinking about it like, wow, I think it is the beer. So I kind of did my own experiment on myself, where I went without the beer for a week, and then I tried to make sure I wasn't doing anything physical to make sure, like, hey, my knee's not gonna randomly hurt. And then I drank the beer, and it blew up. And I was like, wow, this is really weird.
Inflammation.
Yeah, there was something in that beer that was not reacting well with my blown up leg.
These IPAs they've shown have estrogenic mimetics.
Huh.
Yeah.
So,
I'm not saying that that's what it was.
So
but
basically, molecules that mimic hormones in the IPAs is what he said.
And that's what plastics do.
Yeah.
Yeah. And they're blocking the androgen receptor. That's what binds hormones.
Mm-hmm.
And you're seeing these feminizing effects from phthalates, right? There's a lot of environmental epidemiology out there that shows a lot of these features, right? And we're starting to see drops in testosterone globally, right?
Mm-hmm.
It's definitely, it's not a one component, issue.
Yeah,
but
yeah.
This is of serious concern. I think they reported that people consume one debit card of plastic every week or something like that.
Yeah, I saw that stat recently. That's terrible.
Check this out. They've found plastic in just about every tissue in the body, and they've also found the most plastic in the brain. So it can't cross the blood-brain barrier, and for some reason, relative to all the other tissues, it accumulates in the brain even more. And the people who had that more often, or had the highest levels, had Alzheimer's disease.
Oh, wow.
Yes. And guess what? We're seeing astronomical rates of Alzheimer's. Once again, it's back to like, what are we seeing, and what are these trends, and what can we attribute this to, right?
Mm-hmm.
I mean, and plastics are everywhere. So stop using plastic cutting boards. Stop drinking out of plastic bottles that you've left in the sun, right? That's
ideally.
Switch to glass. Stay away from like even these like Teflon and these other materials.
Mm-hmm.
There's a lot of data out there that shows, don't, avoid this, because it's an accumulation effect, right?
Yeah, and sometimes, because growing up poor and low income, we always bought plastic knives and not knives, but forks and spoons and paper plates and, minimized dishes and, and of course, like I've mentioned before on the show where you get a box of strawberries, you see one moldy one, the rest of them don't look moldy. And you're like, oh, just get rid of the moldy one or two. Mm-hmm. But, ultimately our eyes can only see so much, right? And at the, microscopic level, who knows how much like mold is really on there in terms of like.
Well, you're switching them from plastic to mold. I would say yes.
Well, that too.
So the strawberries and the berries are in plastic.
Well, yeah, but
mold. Hold, hang on. And they have probably pesticides, fungicides.
Of course.
You're getting, and that's what so we're at a conference, right? We're in Denver recently, and my student, Marcos Ariaga, presented a poster where he was looking at individuals, and you can find just about every class of these compounds in people's blood plasma. There you go.
Yeah.
Yeah.
And so what I was just trying to get at earlier, though, is...
We shouldn't have these compounds in our body. We shouldn't have these in our bodies, right?
Mm-hmm.
And these were associated with people who had Alzheimer's and who had all types of other, chronic diseases. Liver cancer, fatty liver disease,
Yeah, and I think it's just, for the most part... I don't know if misunderstanding is it's just like you don't know what you don't know. Yeah. It's just awareness. Yeah. So it's like, that's why I love this platform that I have, and it might not reach as many people now as I'd like, but I hope to keep growing it and having this opportunity to share information like this, because so many people microwave their plastics, and that's like one of the worst things you can do.
Yeah, exactly.
And so there's a whole variety of these environmental, like simple daily things that we can do to mitigate and minimize our propensity to getting disease.
Right. Yep.
And so I almost feel like there needs to, maybe that could be part of our grass organization, is putting on like booths in places.
Oh yeah, that's a good idea. Like getting out into the community with your own like program or agenda.
Mm-hmm.
Just giving out like new data that maybe you guys came across, right? That's important. I think I think that's one of the big take homes is that as scientists, we need to communicate better, like this platform, to where people trust us. I know with the whole, I don't want to, stir up, old news, but like with the COVID vaccine and misinformation.
Yeah.
And the thing is, the scientific method and our approach to science is that we have the right to be wrong. We got to be careful, right? We got to make sure that we learn from failure.
Yeah.
Right. Don't waste a good failure, right? That's kind of the motto in the lab, right? You learn from we learn from trial and error, and then we get it right. And that's so.
Yeah, we actually learn more from our failures than our triumphs.
Real scientists, pure scientists who are doing these types of experiments and these type of, there's a lot of stuff that gets out there that are, there's fraudulent, bad actors, right? At the end
as
of
with
the
any
day,
industry.
At the end of the day, like where we've, over the last 100 years, the advancements of medicine and where we're headed is because of, scientific research.
Yeah, there's definitely more good people than bad people in any industry. There's always going to be bad actors, whether it's politics or science or government or, and everything in between.
I mean, I think, science for science sake, but we have to convey that to the community. They have to learn to trust us. There have been, issues in the past, ethical issues. But at the end of the day, we're looking, we're trying to advance and help the community, not just the population, but like globally, right? The world.
Yeah, exactly.
And that's what research does. Because where does this all come from? Right? Where, this all came from somebody's idea, somebody's, research question, somebody who was exploring this.
And then it led to 10,000 more questions.
Exactly, right? So, like, that's one thing that's really, like I said, I'm going to, talk about this again. That's one really great component of UTRGV is more research is coming, right? Or they're trying to work towards bringing more research areas, more disciplines, more PhD programs. So, and then also on the flip side of that, the commercialization of aspect, right? Many times students can get a PhD or get an advanced degree in some discipline and then spin out their own company, right?
Yeah.
And there are really unique ways for the university to facilitate that, right? And so that's here at UTRGV, right? So it's if you look at the Rio Grande Valley, we need more, young people developing new industries, new technologies, creating new hubs. Why do we only have to be like an agricultural center, right? Why not an information center? Data is the new commodity now, right? And guess what? We are generating it down here. So if you have ideas, see them through, right?
Yeah, and that actually reminds me, I have something I want to pitch you after the show in terms of something I came across. But
well, my motto, I'll say yes.
So we're going to take another quick break, and we'll be right back. Thanks for tuning in. All right, everyone, and we're back. So for our final segment for the show, we just want to talk about the conferences that we attended. Me personally, I have been gone for basically the last 2 weeks. The first week I spent in Arizona at a SACNAS conference. It stands for the Society for the Advancement of Chicanos and Native Americans in Science. I believe I got that right. Dr. Galan, lifetime member of the organization, Dr. Galan. And so there it was in Phoenix, Arizona. And I got a travel award, so I didn't have to present, but I did spend the time to go to the different exhibitor booths and talk to different people, go to different sessions to learn. And
do you know the origin of that meeting?
A little bit. Basically, there was 4 Native American scientists in an elevator.
And a couple of Chicano.
Oh, yeah?
Mexican American, yeah.
Yeah. And so they kind of joked that if the elevator crashed, that all the Chicano Native American scientists...
all the minority scientists would have been gone.
Yeah. So, yeah.
In the 70s.
Yeah, so basically 50 years later or so, it's blown up into a major organization and conference. And it was very inspiring to go to because there's a lot of young you know, minorities, people from various
And it's
backgrounds.
inclusive to not just Chicanos and Native
Yeah,
Americans,
yeah.
Puerto Ricans, El
Well, that's
Salvador,
great
everybody.
about it. There's a woman who gave a talk there she was from Iran, so to hear her
Okay, yeah.
story of being an Iranian scientist and growing up in that
Yeah,
culture, and
it's
then
opened up to everybody.
yeah,
Yeah,
yeah.
it's not.
So
Yeah,
that's
that's
what
what's
I'm saying. It was
cool.
super inspiring, and I was so glad to
Great
have gone.
conference.
And what really inspired me the most was attending the NASA sessions because personally, I want to be an astronaut. I meet the minimum qualifications, and so I'm working hard over the next 6 years to kind of pad my resume as much as I can to stick out and be a competitive applicant for future astronaut classes. But with that, I just wanted to share that I've kind of realized that with talking to them over there, the NASA reps, I was talking to them about resumes and applying because I really want this more than anything to be an astronaut. And so I was telling him my story in terms of like listening to the podcasts and trying to learn all that I can. And he basically reaffirmed some things that I knew. And he also told me that, I knew this, but I never really thought about it per se. So he said that being an astronaut is 60 to 70% training for space, getting ready to go to space, being in space,
Hmm.
and, training others and basically being in that world of getting ready to go and train others to go. But the other 30 to 40% is public relations, going to schools and talk shows and universities and organizations and giving speeches and being a kind of a public figure for NASA and the space programs. And so with that, I realized that I need to stop being so introverted. I need people to come along on this journey with me, right? Cuz
Right.
I feel that not only will that make it kind of so the way I think about it, long story short, is that if I can get a gathering of people to watch my journey in pilot training and scuba training and marathon running and all the things I want to try to do to make myself a competitive applicant,
Hmm.
if I get a bunch of followers, it's kind of hard for NASA to be like, man, we should reject this kid who's got 250,000 people following his astronaut journey. He's qualified from hell. He's pilot, scuba, ex-military,
Hmm.
PhD in human genetics, unique experience with this unique animal model we can study, at, you know, um, developmental, things, biological development in space with these
Yeah,
possible
yeah, yeah.
possums.
That's a good project.
Yeah, yeah, and so it's basically inspired me to not give up and to always,
Good.
like I said, because that was really cool about the NASA session was that they were basically telling people you belong at NASA, even if you're not a scientist. We have communications jobs. We need
Yeah.
business people. We need writers.
Yeah, yeah.
We need social media people. We need everything at NASA. So
Right.
you might not feel like you belong, but apply. And that's when I told them like, hey, everybody, don't shut the door on your own face because it's kind of intimidating thing to do.
Yeah. No, you nailed it, man.
Yeah.
Like, don't like you got this one opportunity to like, you know, you're I'm trying to like, formulate you're humans or people or even the individual. All you are is an expression of yourself over time. And whatever that leads to, that's going to be you, right? And I think regret comes from not living up to your true potential and expressing yourself 1000%.
Yeah.
Um, and it's not to say that, and people grow up under different conditions, under different situations. Don't compare yourself to anybody, right? Comparison is the thief of joy.
Yeah.
But you gotta, you have deep down inside, if you really kind of figure yourself out and you know what that pathway that you want to accomplish is,
Hmm.
do it, right?
Yeah, and for me, that's why I was saying, like in my heart of hearts, the more I learn, the more I research, the more I hear stories of actual astronauts who passed astronauts training and are actual NASA astronauts. You hear their stories and you realize they're human beings just like me. Like they're not these 10-foot
No, yeah.
tall,
You know what?
800 IQ, and
And
so they're
that, yeah, yeah.
fallible and they're human and they're astronauts.
And that
And
goes
so that's
to,
why
yeah,
I'm like inspired to do it myself.
right. And that goes to also not listening to the people or the people who say that you're crazy or that you can't do it, right? You gotta be able to like tune that out.
Yeah, for
In
sure.
fact, if I don't hear that, then if I don't hear, oh, that's a crazy idea, you shouldn't do it, then I haven't done, that idea is not good enough. That's the way I see it. Yeah. So I would encourage, like, follow your own instincts. My advice is never take advice. And so just go for it. Like, what do you have to lose, right? What, they say no?
Yeah, exactly.
Okay, you just go on to the next cool thing, right? And just try to follow that passion.
And so real quick, so that was the first week was in Arizona, which was super awesome and inspiring. I got to do so much and talk to different people and learn. And then recently we just got back from Denver for the American Society for Human Genetics conference. It was both Dr. Galan and my first time at the conference, and it was really awesome to go. And the one in Arizona was great, but it was very broad with a whole bunch of different topics. This one was specifically for human genetics and the things that we study and what we do in our department. So I got to give my poster presentation, which was something I haven't done in over 10 years, and it was a really great experience.
And guess what? I'm not a geneticist. And so it was like, and that once again, if you're, as you're like developing and you're gaining, you're becoming, you're developing your own perspective. Maybe you're comfortable in your own element. Let's say you're an engineer. Try something else. Jump on into another field, right? Because all you're doing is allowing yourself to gain a different perspective or a new perspective, and actually incorporate that into the way you've already been doing things, right? Or to integrate these new ideas. That's what happened when I was there. I mean, I don't want to become a geneticist, but now I kind of see what their perspective and their point of view is to now incorporate, new ideas. So it was a really great experience.
It was.
And also, I got out of my comfort zone. Yeah, I had no idea a lot of the times what they were talking about. So I was just, writing mad notes down, right? So, I thought I was done with school, but I guess not.
Yeah,
I got a lot of stuff to learn.
That's what I love about those things is being able to get out of our comfort zones and grow as people. That's really one thing that I've learned in my almost 40 years of being on this earth is the true growth comes from being uncomfortable and making mistakes, because that's just a part of human nature, man. We fell a lot of times before we walked. We couldn't tie our shoes for a long time. We always needed help. And it's just like anything. There's skills that we develop and we grow and learn as we, as time goes on. We just got to learn to stick with it and not give up, because it's easy to put it down and walk away, but sticking with it and grinding through it and developing the skills is where the real gratitude and the real joy comes from. So with that, everyone, thank you for tuning in. Dr. Jacob Galan, thank you for
having me,
being a guest on the show again.
Right on, yep.
And like always, everybody, stay healthy, stay happy, and let's thrive together, RGV.